to be solved. So it's not like that we shouldn't do that. It's just an extra challenge, and that's what the gulp is there's an extra whole bunch of challenges here that at the moment we're mostly punting on.
It was mentioned in passing that you had to replace the hardware in the Aldron platform, so I was wondering whether it would be possible to bring the same high assurance software back to the stock hardware as the original controller, or is this a hard constraint that you can't really work around?
Well, so the original, I mean, Pat can answer better than I, as he's an expert in this topic. The original processor is like an 8-bit processor, very, very small. I think probably, well, why don't you guys answer?
So the AR drone platform that you buy at the store has a small Linux computer in it, like a smartphone. It's closed source. People have reverse engineered parts of it. We didn't want to go through the effort of porting to a strange platform that would have a lot of difficulties along the way. So instead, we just started with an existing open source hardware platform. So that was just a practical concern. It could be done, perhaps.
Okay, thanks.
Maybe my question is somewhat similar, but it is so amazing that you got the secure microkernel, but there is many things, software working to make this OS work. So how do you see this approach? Would it scale to the entire software community that develops the working operating system?
So let's see. So on the Archicopter right now, the Smackcopter, about 80% of the code running on the platform is high assurance. So they've replaced almost all of the code, and in fact, they're working towards replacing all of the code. So for certain embedded systems, we're close to being able to do everything now.
Under control, with trusted teams.
Yeah, so those are different issues. There are lots of issues, but we're close at least to being able to produce an entire high assurance system for a real practical embedded system. We're a long way from being able to do that for the automobile. In fact, nobody actually knows how many lines, well, there's no single person who knows how many lines of code there are in a typical car, because there are all sorts of third-party vendors who are providing pieces of it with proprietary software inside, so even the end manufacturers don't know how many lines of code there are. The answer for something like Linux, which is 10 million lines of code or something, how could you possibly do that? If you sort of break down the system, of that 10 million lines of code, a huge amount of it is device drivers that are for legacy systems, right? So you might decide, like, well, for my platform, I don't need 99% of these device drivers, so I'm going to strip that code out of my system, right? So, and then you take the individual pieces and figure out which parts of those systems need to be high assurance, and make those parts high assurance, and then allow a gradual path to producing the rest of the system in a way that's high assurance, so that you can add it a piece at a time. It's not a fully compelling solution, but I think it's the best answer that we're going to get.
So this is very interesting solution. Do you think that within that traditional history, does the secure software have to coexist with the insecure software? How would you do that?
Right, so I think that clearly we're going to need to have insecure software coexisting with secure software. And in fact, that's part of the phase 2 of the AIR team, right? There was the red box of let the red team put whatever code they want here and have the rest of the system be such that it's still provably correct. No matter what goes in that red box, the rest of the system is guaranteed to have the properties that we want. And so I think that's a path towards getting systems that even if a hacker is able to break in, the damage that the hacker can do is constrained.
Last question, maybe Leonard.
Let me put on my tinfoil hat.
Okay.
How do you know that the hardware that this is running on doesn't have designed-in vulnerabilities?
Right. Yeah, you totally don't. So that's another problem that actually colleagues at DARPA have been working on. Right, so for the purposes of HACMS, it's like the problem that we bit off is hard enough already that we drew the line to say we were going to trust the hardware. But for example, the FBI found maybe 5 years ago that the Navy had bought 35,000 counterfeit routers that were exfiltrating information. And, right, you know how they found that they had counterfeit routers? An auditor was like, why are these routers so cheap? They only cost 20% of the going market rate. So like the group that was responsible for the counterfeit routers who charged like 95% of the going rate, then maybe they would have never discovered that they were running counterfeit routers. So yeah, so reliability of hardware is another very important problem that needs to be solved, but that's not what we were trying to solve in HACMS.
Great. Thank you very much for this exciting talk. We are going to have a break now, and if the speakers of the next session could please approach the session chair, Anil, who is back there waving, Mr. Xing t-shirt, and get in touch with him. Yeah, the rest of you come break. Thank you very much.
Shall I press begin? Yeah.